Hello everyone, welcome back to the Engineering Geology Webinar BE channel. In this channel, latest geological and geotechnical insights applicable to various projects such as mining engineering projects, civil engineering projects, water infrastructure, and irrigation infrastructure projects will be discussed. My name is Dr. Branu Ermias, and I am an assistant professor of engineering geology and a freelancer as geological and geotechnical expert. Today, I am going to teach about the best method for rapid stability assessment of excavated rock slopes in the field. In episode 1, I had listed 6 of the empirically derived rock mass characterization methods used to develop safe slope, appropriate support and reinforcement. These are the 6 methods listed in episode 1. In this episode 2, we will see the advantage and the limitations of each of these methods and identify the best method we have to use for rapid assessment of excavated rock slopes in the field. The first system is known as Q system, and this system is used for characterizing rock exposures in a drill core and for estimating single shell support and reinforcements needs in tunnels, caverns, and mine roadways. So the second method is known as rock mass rating, which is used for frequently in underground workers, while its use is scarce in slopes and dam foundations. The limitations of these two methods, Q system and the rock mass rating, is that they are not effective when dealing with rocks, overstressed rocks, and in dealing with problems like rock bursting, squeezing, swelling rocks, and when dealing with faults and weak zones. These methods have limitations. The third method is known as slope mass rating method, and this slope mass rating proposed by Romana is used to predict support, reinforcement, and the performance of excavated slopes. The limitation with this slope mass rating is that it does not take into account the height of the slope, which is important in high slopes. The fourth method system is known as modified rock mass rating of Unal et al. 1992, and this method is a modified version of Bianisky's 1989 rock mass rating. It has with additional features to suit a wider range of rock mass conditions, including weak, stratified, anisotropic, and clay-bearing rock masses. The fifth method is known as Global Slope Performance Index of Sullivan, proposed in 2013. This method is used for all slopes greater than 30 meters in height to predict slope performance and associated risks. When we see all of the methods above 1 to 5, the limitations or the problems of these methods to be used for rapid assessment of excavated rock slope stability in the field is that all of the above methods, the 5 methods, will not provide a guidance on the long-term stable slope angles for excavated rock slopes. They don't indicate the long-term stable slopes, or the 5 of the methods discussed above, they don't indicate the stable long-term stable slope angles, and they don't provide guidance on determining these slope angles where reinforcement and supports are deliberately absent. So the 5 methods discussed above they provide support systems and reinforcement systems. The only system or technique that can be applied in road, rail cuttings, in motorway cuttings, in benches, in open cast mines to rapidly assess the suitability or the stability of excavated rock slopes in the field is known as Q slope method. What makes this method different from the others is that it provides guidance to appropriate long-term stable slope angles in which rock reinforcement and support are deliberately absent. So this is the only technique that provides guidance on the appropriate long-term stable slope angles, how to determine long-term stable slope angle, provides guidance. So that makes this method different from the other methods described above. So engineers or geotechnical engineers or engineering geologists working on site, those who want to make the modifications on the angle, slope angle or cutting angle to create long-term stable slopes and avoid reinforcement and support. So the Q-slope method will be the best method. So since this method is the best method, we will discuss this method in detail. So in order to understand this method, we have to see the intention of this method. So this method, Q-slope method, is empirically derived for stability or assessing stability of excavated rock slopes in the field. It is intended for use in reinforcement-free road, railway cuttings, or in open cast mines. So this method allows geotechnical engineers to make potential adjustments to slope angles as the rock mass conditions become visible during construction. Before construction, during the design time, the different slope stability analysis techniques could have been carried out. Based on that, the design will be completed, and then during the construction. But the actual ground condition, the rock condition, will be visible when excavation is undertaken. At that time, the site, the engineering geologists or geotechnical engineers that are working on that excavation site, they can make potential adjustments to slope angles to create long-term stable slopes by employing Q-slope angle. So in this regard, the Q-slope angle is very useful for site engineers in order to make the potential adjustments. The prime areas of application of this method is for bench angle decisions in open pits, and also for numerous slope cuttings needed to reach remote hydropower projects, such as tunnel projects, bridge projects, dam projects located in remote areas. Access roads may be required, and these access roads require cuttings to provide stable, long-term stable slopes of these road cuttings to access these important project sites. So potential adjustment of slope angles may be required to create safe slopes. Therefore, in these areas, Q-slope method can be applied. It is important to understand also where this Q-slope angle is not intended to be used for. Q-slope method is not intended for assessing the stability of large slopes developed by several excavation stages over significant period of time. What is the problem with large slopes? I will give you more information about large slopes. So because the Q-slope angle is intended for bench angle decisions in open pits, and also for numerous slope cuttings. It is intended to handle local failures, not large slope failures. And I will give you more information about large slopes, the problems related with large slopes, and other interesting information will be provided in episode 3. Therefore, subscribe to the channel to stay tuned to all the episodes. Thank you.